UCS was designed to operate at scale, which means that when Cisco looked at the fact that, hey, we can create as many vNICs as we want per server, and, well, we support 120 servers, so 10 vNICs, yeah, that's a whole lot of vNICs. How do we get around that? How do we improve the ability to manage that? And what we have is something called vNIC templates, so the ability to use a template to create additional vNICs in our environment. In this video, we're going to explore exactly how vNIC templates work. When we're creating a service profile in UCS, really what we're doing is we're creating the identity points and the policies around what a server is going to be. So this server will be deployed onto physical hardware. We just don't have the physical hardware yet. So really, we're defining in software what this hardware is going to look like. Now, as we discussed in the UCS basic networking skill, we're probably going to have a lot of vNICs per server. And there's a number of reasons for that. If you aren't familiar with that concept, then I encourage you to go back and check out that skill. So we might realistically have 10, 12 vNICs per server. And that's a lot. That's a lot of vNICs in our environment. And we already covered how we dole MAC addresses out. We use that resource pool and we get the MAC addresses assigned. But what about the creation of these vNICs? How do we actually create all of these in a timely fashion? If we have to create 12 per service profile, oh my goodness, that can take a while. Fortunately, Cisco gives us vNIC templates. So we create a template and we use that template to spawn multiple vNICs. And the configuration is very similar to actually configuring a vNIC. We configure a lot of the same options. We assign it the resource pool, for example. We do have to define which fabric it's on. So are you on fabric A or are you on fabric B? And that usually means that we're going to have to configure two different templates per NIC, right? So back to this example over on the left, if we have a vSwitch here and we have connections to these two vNICs, this vNIC will be attached to fabric A, and this vNIC will be attached to fabric B. Now, we might have failover configured, but that doesn't change the fact that these are bound to one fabric. They're always bound to only one fabric, and we usually want to set them up even with failover such that one is on fabric A and one is on fabric B. So what that means is when we're creating a vNIC type, let's say we want a vNIC for data, we're going to want to create two templates, one for A and one for B. Now for what's probably the most important concept within vNIC templates, and not just vNIC templates, but really other templates within UCS as well. Cisco defines for us two different types of templates. We have an updating template and we have an initial template. And these have very different properties and they're used for two very different purposes. So let's walk through an example to see how this works. Let's say I create an updating vNIC template. So here's my template. And I use it to create three different vNICs. So we have three different vNICs. Maybe they're on three different servers. Maybe they're all on the same server. And all of these vNICs, they have VLANs 10 through 15 on them. I added those. It was working. It was great. And then somebody came to me and said, hey, we need to add another VLAN. We need to add VLAN 16 to the mix. And we say, oh, okay, well, I'm going to have to go out and touch all three of those vNICs. Or let's say it's a larger environment. What if I have 50 vNICs? I need to add a VLAN to all 50 vNICs at once? That's going to take a while. Fortunately, I used an updating template. And so all I need to do is come back to this template, add VLAN 16, and 16 is added automatically to all of the downstream vNICs. Now that has a very good property, and it can have a very negative property. The good side of it is it's going to save me a lot of time. The bad news is mistakes can be made with updating templates. If I get on here and I add something that is going to maybe cause disruption to the network, and it gets pushed down to all of the vNICs all at once, it's going to cause problems. So use updating templates cautiously. Now, if the scale of your environment doesn't warrant having an updating template, meaning maybe I do only have 10 vNICs, and if I have to change that, then not a big deal. Then maybe an initial template is where we want to go. So again, in our example, we create a vNIC template, and we spin up our three different vNICs. And when I want to add that 16th VLAN, so again, we have 10 through 15 enabled, and we need to add 16. I do actually have to come back and manually add 16 to every single one of these. So it does create more work for me in the scenario where I have to make a change to all of the vNICs in the environment. But it also saves me the potential headache of, oops, I made a change here, and it got automatically pushed down. So making the change on the template is very safe with initial templates. In the end, you need to use what's right for your environment. vNIC templates are designed to improve our manageability of the environment. First of all, they can help us spin up multiple vNICs, and keep in mind we usually need a vNIC template for Fabric A and Fabric B. Second, updating templates allow us to manage an environment with a large number of vNICs, but we do have to use it cautiously because we can accidentally use an updating template to cause problems in the infrastructure. I hope this has been informative for you, and I'd like to thank you for viewing.